want to be an assessor?
Hello, we're back.
We're back. Welcome to another week of So You Want to Be an Assessor. I am your co-host, Kaitlyn Reeder, joined today by
Mei Beth Shepherd, and so excited to be here. We are going to be talking about some terminology, I think, is what we decided. We're going to talk about calibration and verification. So, I don't know, this may be really short. But let's see what happens.
Yeah. I know these terms I can toss around willy-nilly, but they do actually mean two different things. So let me see if I have this right. Calibration is like the actual instrument getting calibrated or tested to get what it should be. You know, to say that 1 gram is 1 gram is 1 gram, straight across the board. Verification is making sure that it's actually getting what it should be. I'm not sure if I'm saying this right.
I know it's very confusing and hard to wrap your head around. So let's narrow things down a little bit just to make it easier. Let's talk about balances. Okay, balances get calibrated once a year. You have somebody come in and calibrate the balance. In my mind, calibrating means that you can change the settings on the instrument, in this case, the balance, so that 1 is 1.
Got it.
Verification, on the other hand, which is what labs do every day, they verify their balances, still see 1 as 1. And so they don't ever change the instrument, the balance itself. They just say, yeah, it's still good. Okay, I put this on it and it still measures what I would need within the plus or minus 2% or whatever numbers you're using.
So a balance can get calibrated because you can change the internal mechanism to make it match 1 is 1 versus say like a liquid and glass thermometer that is, a little bit harder to change because it is literally, substance inside of glass. You can't change. And so that would be more of a verification style.
Well, yeah, but I don't know. The NIST thermometers that you buy, you buy those things and you can get them certified as verified to NIST for up to 5 years. You could probably ask for more, but most people kind of limit it at 5 years at the top end. Okay. And you can send those back, right? You can send them to the manufacturer or whatever to get re-verified. Now, I don't know if they are out of range, if they just send you a new one, or how, if they heat up the glass so that it's thinner. I don't know.
They do some science and they alter it.
Yeah, they would have to change the thermometer somehow. Do something to change it. I don't know if that's possible or not. There's probably somebody who's watching that can tell us.
If you're that person, put it down in the doobly-doo. We'd love to pick your brain.
Yeah, tell us, help us spread correct information instead of just our opinions. But
well, some of the NIST are like thermocouples, and so they do have a digital component. So I could see those being easier to calibrate than the old school mercury thermometers. Of course, if it's mercury, then it's probably pretty darn accurate.
It should be pretty darn accurate. And the problem would be whether the column breaks or meaning the column of mercury. And I've seen thermometers where the column split inside the glass encasing, and then it doesn't work right because it doesn't know what to do with that space. Mercury acts like Mercury all the time. It's one of those things. And it doesn't, since it's not all connected, it doesn't always spread at the same amount or not. Anyway, so that's calibration, I think, is changing. Now, your instruments like your GCs and your LCs, HPLCs, your all of the ICs, all of those things, you calibrate those by confirming through a range of volumes, I guess volume is the right word, amounts, how the instrument is responding to a particular analyte. And so therefore you calibrate and say, my instrument is responding this way right now, and this is what we're going to use as our numbers. Many times you use internal standards that you shoot at the same time to say, okay, if it comes out with 1,000 area count, then I use that 1,000 area count to calculate how much 1,000 area counts of another analyte that reacts the same way is going to respond. But you figure all that out with the calibration, which is running the multiple levels of points of your calibration. The stuff, you know what it is. I remember going into one lab that was, it was not an environmental lab, and so it was a 17025 lab, and I was just blown away by the fact that they didn't have a standard. I'm like going, but how do you know it's what you're saying it is? And they're like, well, that's the only thing in there. I'm like, well, pardon me if I don't believe you. I think it was a food something, but I don't remember well enough to know what it was. But I remember being, but what is it? How do you know what it is? And with any accuracy, if you don't have the real thing to compare it against.
That is so wild.
I know. And maybe that's just because I come from the environmental background where we're comparing. I mean, all these silly PFASs, silly. I can say that now. We never used to know about these forever chemicals. They have been showing that they've been in every sample since forever, evidently. But we don't know what we don't know. So there's a peak, and it comes out at the same time as the standard of that. And so we call it this. We're getting better. Things like the mass spectrometers, et cetera, that also allow us to say, okay, and when it broke down into these different sizes and pieces, and in this kind of a proportion, are going to, help us get more of a feel that we're right on what we're saying it is. But we still can't be 100% because
we are just less uncertain.
Exactly. That whole uncertainty thing. This is why 17025 people are very big on uncertainty. The environmental world, this is one of the things that we have learned as we work with third-party accreditation bodies that do 17025. 17025 is so big on uncertainty because it's such a big part. In the environmental world, we're like, yeah, uncertainty, whatever. We know it's not 100% accurate, but we're good enough. And because we are more certain than just, shooting something and saying, I think that's ethanol. How do you know? How do you have any clue? Because it's not like you can look at it. You'd have to look at it under a microscope, and you can't do that on every sample or whatever. And when it's under a microscope and you've gone through the trouble of getting it onto a slide and figuring out what it's supposed to look like, et cetera, and trying to break it down, you can't get a volume or how much is something. So anyway, calibration versus verification.
We detoured into a different type of calibration.
So you calibrate instruments on, sometimes it's a daily basis, but with multiple levels of and then you do calibration verifications on instruments.
ICV, your CCV.
There's two types. The ICV, which is a second source typically, and your CCV, which is a continuing calibration verification, which is similar to on the balance, every day going out and saying, okay, here's my official 5 gram weight. I'm going to put it on the balance. Is it close enough to 5 grams? With the CCV, you shoot it and say, I'm expecting a 5. What number are you going to give me? And so,
5.
Hopefully it's a 5 and it's within a certain percentage. That's how those are calculated. So, so a verification, whether it's on a fancy instrument or whether it's on a balance, is the same. You are not actually changing the instrument. You are just confirming that the instrument is reporting what you think it's going to report.
Okay. So not to add a little wrinkle, but it did just pop into my brain. So naturally I have to ask you about it.
We stream of consciousness talking. That's how we do this.
Conductivity.
Conductivity is, we said Mercury acts like Mercury. So conductivity has a cell constant. It has a thing in the instrument, whether it's one of those little proby things or whether it's instruments or, you know, whatever.
All the ways that they appear.
It has a cell constant. It has something that's usually, I think potassium iodide is at 1413. So that's its norm. So you want to make sure that your cell constant is constant. You don't calibrate it because you're verifying it, because you can't change Mercury to be something else without a whole lot of work. You don't change the cell constant in conductivity meters to be something different. And so same thing. You're verified with that one. You can't, Mike, that's one of his favorite arguments, is you cannot calibrate a conductivity meter because it is just a cell constant. So what you have to do with those is you have to verify it with 2 sources. So you need to verify it at 1413, or I don't care whether you do that as your first source.
The typical one, yeah.
Or you could have one that's verified from your provider when you buy the little conductivity standard at 1412. I think that it comes in both. I'm pretty sure it's whatever they're using to read. Their instrument. But anyway, so yes, that's a little bit different in that it's
not necessarily a calibration, more of a verification of the internal mechanism itself, because there is no calibrating necessarily.
Right. It's that piece of equipment with that standard always responds this way. It's just one of the, is it a fact of nature? I don't know. It's something that's out there to
It is the fact of the environmental laboratory nature, and we're sticking to it.
We're going to go with that. We're going to go with that. So that's, yeah. Are there other questions you've heard, we've heard?
On calibration versus verification?
Calibration versus verification.
I know IR guns often get brought up because they are battery operated devices and they do have internal mechanisms, and no one seems to really agree on how often they need to be verified and or calibrated, and they use all sorts of different verbiage, which weirdly enough has different meanings.
Right. Agreed. And they're kind of strange because they fall under, in the TNI world, they fall under the electronic or digital thermometers, which have a different requirement. My thought on IR guns is they're probably more accurate than regular thermometers, if nothing else, because I can read the number that's that big versus look at the little line of where and where is this line? My meniscus in my thermometer. There's that little detail.
But the highly interpretive science of thermometer temperature taking.
Yes. Well, and so IR guns, it's kind of like they also have an internal thing. They can be verified just like any other thermometer. You can shoot it at a piece of ice, and hopefully you're getting 0 if you're measuring in Celsius, and you can shoot it at boiling water, and hopefully you're going to get 100. But they can also be modified because they can be taken apart. So I would call, again, the modification, going in and changing it, I would call that calibrating it. I would call anything else verifying it, and that usually has to be done quarterly. Or am I getting my DoD requirements confused? I don't remember if it's annual or quarterly, but
I think it's quarterly for DoD. The new micro says semi-annually.
Okay.
Micro digital thermometers. And then there's one more that says something else, which is, again, very confusing. Why I have to keep all this in my brain for all these different rules. And if they get confused while we're on site, please tell us where we're getting that.
We can look it up. We all can look it up. It's not privileged information that we are not all allowed to get to.
No, I've often say I've got like 3 discrete cups of information, and sometimes they stay where they're supposed to, and then sometimes they tip over and it gets all jumbled. More times than not, at least 2 of them are tipped over. So I have to be like, oh, this goes into that cup, this goes into that cup.
Yeah.
I need to sort it out so I can remember where I'm coming from.
I love it. We're using analogies like, I'm thinking cooking, baking here. Not that I'm a big baker, but it's like we're using analogies of that. Somebody else would probably use sports analogies, but I can't go. I have no clue. We can't go there.
So what's happening right now? I have no idea.
Yeah, I think we're at the end of March, so we're in March Madness something. I think that's basketball. But
couldn't tell you.
The big round ball got orange usually with black, whatever. See, this is the things I know about sports. All right, I think that we have covered calibration and verification. If you have questions, if there was something that we didn't cover, then please let us know. Ask. We'll try and get an answer. Make one up if nothing else. Not doing it on purpose, but anyway. So let us know if there's any other topics you would like to hear about. We would enjoy branching out. Yeah.
Drop them in the doobly-doo.
They very fancily named doobly-doos. And
Comment box.
comment box.
Doobly-doo.
I like it.
Thank
So, okay.
As always, if you like our content, please like and subscribe. It helps the channel get to where it needs to go, hopefully. There's a bell in the corner if you want to be notified of any time that our podcast drops. We are currently sticking to our goal of twice a month. Go team. So we hope to continue that through this year, probably till about holiday time where we'll drop off again because we got holiday stuff to do.
Yeah, there's the holiday stuff. Okay.
So we do like doing these. They're super fun. And you know,
hopefully they're helpful to somebody.
Yeah.
Somewhere.
Hopefully like them.
Yeah. Let us know. Okay. Bye.